Quicksort. Quicksort is a fast sorting algorithm. On an average, it has O of n log n complexity, making quicksort suitable for sorting big data volumes. It divides the objects into two for every iteration. Algorithm. The divide and conquer strategy is used in quicksort. Choose a pivot value. We take the value of the middle element as a pivot value, but it can be any value which is in range of sorted values even if it doesn't present in the array. Partition. Rearrange elements in such a way that all elements which are lesser than the pivot go to the left part of the array and all elements greater than the pivot go to the right part of the array. Values equal to the pivot can stay in any part of the array. Notice that array may be divided in non-equal parts. Sort both parts. Apply quicksort algorithm recursively to the left and the right parts. Partition algorithm in detail. There are two indices I and j, and at the very beginning of the partition algorithm, I points to the first element in the array and j points to the last one. Then algorithm moves I forward until an element with value greater or equal to the pivot is found. Index j is moved backward until an element with value lesser or equal to the pivot is found. If I is lesser than equal to j, then they are swapped, and I steps to the next position. I plus 1, j steps to the previous one, j minus 1. Algorithm stops when I becomes greater than j. After partition, all values before ith element are less or equal than the pivot, and all values after jth element are greater or equal to the pivot. Example, sort 1, 12, 5, 26, 7, 14, 3, 7, 2 using quicksort. 1, 12, 5, 26, 7, 14, 3, 7, 2. Unsorted array. At the beginning, 7 is the pivot value. As per the algorithm, the steps moves. Notice that we show here only the first recursion step in order not to make the example too long. But in fact, 1, 2, 5, 7, 3 and 14, 7, 26, 12 are sorted then recursively. Complexity analysis. On the average, quicksort has O of n log n complexity, but strong proof of this fact is not trivial and not presented here. Still, you can find the proof in the worst case, quicksort runs O of n to the power of 2 times, but on the most practical data it works just fine and outperforms other O of n log n sorting algorithms. Code snippets. The snippets show how quicksort is working. It should be implemented using C++. The left and the right are pointers like we said in I and J.